So Jānis Šteinbergs, next speaker, with e-poster statistical properties of a galactic magnetized warm and ionized medium. So floor is yours, and you can share your screen.
Okay, I will start. So I will present preliminary results for projects of statistical properties of galactic magnetized and warm ionized medium. So this is I'm doing together with Kristaps and me from Virac and Marco Iacobelli from the Astron. Let me go to the next slide. So what we are doing, we try to use pulsars. We try to use pulsars to probe warm and magnetized this medium in galactic in galaxy. So we're trying to use rotation measure and dispersion measure and the distance is measured, and all the theoretical details are described in the posters, and you can check it later. And if you are interested, I can discuss it afterwards. So why we are doing this? So first of all, comparing the data samples, size of the samples in 1993 and now, it's about very much more than before, and we want to update the previous studies. So what you see here is comparing our sample with ownership data sample that was in 1993, and you see that in our sample, ownership data sample is in the center, and we have much more pulsars data that show. What our aim is to create 3D maps of galactic magnetized warm and ionized medium, so as tool to investigate spatial properties of galactic magnetic fields and turbulence in interstellar plasma. So now I show the turbulence component, how we try to study turbulence component of magnetic fields. So here we try to do again work of ownership data in 1993, and this is initial results. We're trying to do simple statistical models of magnetic fields, and as already mentioned, you can see we have much more sample of data than it was available few decades ago. Let me go to the last part. So in the last part, we also try to redone the work of Brian and Gensler in 2008, and here we try to create a geometrical models of warm and ionized medium, and we are trying to fitting that with the equation that you see here, and our input for the fit is distance from the midplane of a galaxy in the parsecs, and when what we try to get out is height of galaxy plane and thermal density of electrons, and we have two fits to all data and fits galactic longitude larger than 40 degrees, and you can see the difference in the values and result what we are getting. And thank you for your attention.
Thank you a lot. Is that right? All this data related to ELT consortium, right, Jānis?
No, this is not ELT. This is, we are using NTFA data that is telescope array in Australia. So this is not ELT data. So.
Okay, so sorry, I misplaced it. Thanks a lot.